Hello everyone, I'm going through the questions in the mid-year exam revision package, the questions under forces. So for question one says a person push a box, so there is a force applied, but the box did not move. So what is the impact on the work done? So if you remember, work done is calculated by force multiplied by the distance. The force applied multiplied by the distance moved by the object in the direction of the force. So in order for work to be done, first of all, you must apply a force. So in this case, the object is being pushed, so there is a pushing force. But did the object move in the same direction that you are pushing the box? The answer is no, because the box did not move. So if D is equals to 0, then we will say that work done is also equals to 0. So no work is done on the box. Let's carry on. For question 2, friction. Question 2 talks about a box being placed on a paper and how can you reduce the friction. Now, the friction is determined by the roughness of the two surfaces. So the rougher the surface is, so if I look at it microscopically, it will look like this. So the other surface may look like this. So the rougher the surface, the larger the friction. So in order to reduce this, one of a good method would be, of course, to apply lubricant. Some of the common lubricant will be things like wax, oil. Of course, you can use water as well, but it doesn't work as well as wax or oil. And of course, most of the time we will also combine it by polishing and making the surface smoother. So the smoother it is, the lesser the friction. When you push them over a short distance and applying less force, all these things does not help to change the friction because basically we look at the surfaces that's in contact. Let's go on to question 3. Question 3 talks about electrostatic force. Now, let's recall electrostatic force is the force between charges. So there are only two types of charges, positive charges and negative charges. So it can be attractive, it can be repulsive. So like charges, they will repel. And then if you have unlike charges, they will attract. So this is electrostatic force. And so which one is an example? Now the ball moving towards the ground, so that is actually gravitational force. All right. An electrical lamp lights up. This is actually electrical energy. Okay, so that's due to electrical energy, electricity. Magnev train, this is definitely magnetic force, a bullet train. So that's caused by magnetic force. And our hair sticking to the comb. Maybe I'd like to show you a picture to show you what happens when you comb your hair. So this is what happens when before you comb your hair, there are already charges present in your comb, positive, negative charges. Excuse me. And your hair, positive, negative charges, they're all there. But because the number of positive and negative charges in your hair and comb are the same, then there's no attraction or repulsion. Now, when you repeatedly comb your hair up and down, now this motion, this rubbing motion, is going to cause some um, charging. So when you rub two insulators together, you are actually charging it. Now, charging it means you make one object more positive and the other object more negative. So in this case, when you keep um, combing your hair, then what happens now is that the hair now has got more negative charges. So if you look here, there are more negative charges and there are more positive charges. When you are in the upper set, you will learn more about the transfer, of electrons that make this happen. But at the present moment, you just need to know that when you keep rubbing your hair, when you keep combing your hair, it results in charging. Charging means something becomes more positive, one object becomes more positive, one object becomes more negative. So when that happens, because they are oppositely charged now, so after combing a few times, when you bring your comb near to your hair automatically gets attracted because this is electrostatic force of attraction. This will not happen when your hair is wet, by the way, because when your hair is wet, um, the charges cannot form when you rub. Let's continue with question 4. Now, question 4, there are three forces and you are asked to find resultant force. So take note that for questions like that, we look at the arrowheads. Okay, it doesn't matter whether this 10 newtons is applied on the right hand side or the left hand side. What is important is what direction is the force being applied. So both are facing the right hand side. So in the right hand side, we have 10 newtons plus 7. So that's 17. And the force that's acting on the left hand side is 4 newtons. So therefore, the resultant force will be 17 minus 4, and you have 13 newtons. And the direction, now this is the bigger force. So the direction will follow the direction of the bigger force. So it's actually 13 newtons to the right. But in this case, the question did not ask for the direction, so we don't have to put it down. Let's look at question 5. Now, for question 5, they ask which one will not happen when you apply a force to a rubber ball rolling on the floor? Effects of forces. Forces can change. So forces, we know that you can change the speed of an object. You can also change the direction that the object is moving. So these are what we call effects of forces. And we can also change the shape. Now a ball is rubbery, so changing its shape is highly possible, right? So if you kick a ball or you can even stop a ball, all these are changes to the speed, changes the direction. But a ball will not be able to change its mass. So remember, mass is the amount of substance in a body. So it is the number of atoms and molecules in that body. So no matter how you push or you pull the ball, the number of atoms in that body and the size of these atoms will still remain the same. They may change the shape a bit. Not the atoms change the shape, but the ball may change the shape because of the rearrangement. But each atom, the number and the size still remain the same. So the force will not be able to change that. Let's go on to question 6. Question 6 is again a question on resultant force. And they again, what we do is we will look at all these directions. So the two that I've highlighted are 14 plus 8. They are acting towards the left, and then 3 plus 10 is acting towards the right. So in this case, so towards the left is 14 plus 8. So that will be 22 newtons to the right. And then to the left is 10 plus 3, 13 newtons to the left. So again, we will know that this is a bigger number. The 22 is a bigger number. So the direction of the resultant force will be to the left. And 22 minus 13, and then we get 9 newtons. Let's move on. Question 7. Now, question 7, which one is not an effect of force? Well, if you look at the first one, parachute falling towards the ground, so that is gravitational force. A windmill turning, the wind is actually turning the windmill, so that is like a pushing, so that is pushing force. So the object is being pushed, so that's definitely a force. All right, push. Repulsion, that will be magnetic force. Okay, so but a piece of ice melting, basically they have more energy, and with more energy, the particles are able to overcome the attraction between the particles in the solid ice, and then start to move more and become a liquid. But that is not a result of force. Let's carry on to question 8. For question 8, which of the following does not reduce the friction? When you apply oil, when you add rollers, And when you polish the floor, all this will reduce friction, because when you polish the floor, you make the surface smoother. When you apply oil again, what you do is you smoothen the surface, so applying lubricant. Adding rollers, the reason is because the rolling action actually reduces friction compared to a dragging. So anytime you roll something, you actually, this way of movement reduces the friction, the rolling motion compared to dragging. So that's why when you have wheels, when you have rollers, or when you have ball bearings are spheres. So when you put ball bearings in between, the spheres will move. So that's a rolling motion. So that also reduces friction. But again, whether you pull the box with a larger force, smaller force, it does not have any impact on the friction. Question 9. Which one is true about weight? So a little revision. This is the formula for weight. W equals to mg. So weight definitely depends on the mass. The larger the mass, the larger the weight. And let's not forget G. G is the gravitational field strength. And this depends on which planet you are in. Certain planet has a larger gravitational field strength. Gravitational field strength means how much gravitational force acts on 1 kilogram of mass. And since the first question talks about the moon, now on the moon is about 1.7 newtons per kilogram. This is the gravitational field strength on the moon. So which means every 1 kilogram of mass, the moon is going to pull it down with a force of 1.7 newtons. So when that happens, then 2 kilogram will be 2 times 1.7, 3 kilograms, 3 times 1.7, and so on. So if you look at the options, the first one cannot be correct because it will not be 0, because on the moon there is still a gravitational field strength. So this is false. No, weight is gravitational force. It's a kind of force, so it is measured in newtons, not kilogram. The weight is always the same in any location. Again, it's force. You go to different planet. Of course, within the Earth, the variation is not very large. Even when you go right on top of a mountain, the G is just very slightly different from when you are at ground, at sea level. But if you go to another planet, the G value may change, then the W, the weight will change. Okay, so D is the correct statement. It's the force of gravity acting on an object. So question 10, the gravitational field strength of the moon, of the Earth, is 6 times, because the Earth is a bigger planet. So the gravitational field strength of the Earth is 6 times that of the moon. And so which one is true? So the gravitational field strength on the Earth is actually larger. Maybe I won't even write the numbers first. I'll just say it's larger than, okay, it's larger than the gravitational field strength on the moon. So of course, remember W equals to mg. So if your gravitational field strength is larger, then your weight will be larger. So then C is the answer, because your weight will be greater on the Earth than on the moon, since on Earth, the value of G is larger. You can go on to watch the other videos for question 11 onwards.